Welcome to this lecture on software process activities. In the field of software engineering, the development of complex software systems requires a systematic and well-defined approach. Software process activities are the key steps involved in the software development life cycle, guiding engineers through the stages of software specification, development, validation, and evolution. In this lecture, we will explore each of these activities in detail, focusing on their objectives, sub-activities, and their significance in the overall software development process. Software specification. Software specification is the initial phase in the software development process. It involves understanding and documenting the requirements and constraints of the software system. During this activity, software engineers work closely with stakeholders to elicit and analyze their needs, expectations, and desired functionalities. The sub-activities within software specification include requirements elicitation, requirements analysis, and requirements documentation. These sub-activities ensure that a clear and unambiguous specification is established, serving as a foundation for the subsequent development stages. Development. The development activity involves transforming the software requirements specified in the previous phase into a working software system. It encompasses activities such as system design, coding, and component integration. System design focuses on creating an architectural blueprint for the software system, defining the structure, interfaces, and relationships between components. Coding involves writing the actual source code, implementing the desired functionalities, and adhering to coding standards. Component integration brings together individual software modules or components to create a cohesive and functioning system. Validation. The validation activity ensures that the developed software system meets the specified requirements and performs as intended. It involves various testing activities to detect and eliminate defects, verify functionality, and assess the system's performance. The sub-activities within validation include unit testing, integration testing, system testing, and user acceptance testing. Unit testing involves testing individual software units or components, while integration testing focuses on testing the interactions between integrated components. System testing verifies the system's overall functionality, and user acceptance testing involves validating the system from the end user's perspective. Evolution. Software systems evolve over time due to changing requirements, advancements in technology, or the need for improvements. The evolution activity focuses on modifying and enhancing the software system to meet evolving needs and address issues that arise during its usage. Sub-activities within evolution include maintenance, updates and upgrades, configuration management, and re-engineering. Maintenance involves fixing bugs, addressing user-reported issues, and ensuring the software system's continued functionality. Updates and upgrades introduce new features or improvements. Configuration management ensures proper control and documentation of changes, and re-engineering involves restructuring or modifying the system to improve its performance or maintainability. By understanding and effectively implementing these software process activities, software engineers can ensure the successful development, validation, and evolution of software systems. Each activity plays a crucial role in guiding the software development life cycle and ensuring the delivery of high-quality software that meets user requirements. So, Let's delve deeper into each of these activities to gain a comprehensive understanding of their sub-activities, challenges, and best practices. Software specification. The first activity in the software development process is software specification. This activity involves defining the requirements and constraints of the software system. Let's delve into the sub-activities of software specification. A. Requirements elicitation. During this sub-activity, software engineers gather requirements from stakeholders, such as clients, users, and business owners. For example, imagine a team working on developing a mobile banking application. They would engage with banking customers and employees to understand their needs, such as secure authentication, fund transfer, and transaction history. B. Requirements analysis. Once the requirements are collected, they undergo analysis to ensure clarity, consistency, and feasibility. This sub-activity involves identifying dependencies, conflicts, and ambiguities in the requirements. In our mobile banking application example, the team would analyze the gathered requirements to prioritize features and resolve any conflicting requests. See requirements documentation. The analyzed requirements are documented in a structured manner. This sub-activity includes creating a software requirements specification, SRS, document. The SRS document serves as a blueprint that captures the functional and non-functional requirements of the system. In our mobile banking application scenario, the SRS document would outline the features, user interfaces, security requirements, and performance expectations. Development. Once the software requirements are specified, the development phase begins. This activity involves transforming the requirements into a working software system. Let's explore the sub-activities of the development process. A. System design. During this sub-activity, the overall system architecture and structure are defined. Design decisions are made regarding the system's modules, components, and interfaces. For example, in our mobile banking application, the system design would involve determining the architecture of the backend server, the user interface design for the mobile app, and the integration points with third-party payment gateways. B. Coding. The coding sub-activity involves writing the source code based on the design specifications. Programmers utilize programming languages, frameworks, and development tools to implement the system's functionalities. In our mobile banking application, the coding sub-activity would involve writing the code for features like user registration, account management, and transaction processing. C. Component integration. Once the individual components are developed, they need to be integrated into a cohesive and functioning system. This sub-activity involves combining the software modules and verifying their interactions and compatibility. In our mobile banking application example, the components developed by different team members, such as the front-end and back-end modules, are integrated to ensure seamless communication and data flow. Validation. Validation ensures that the software system meets the specified requirements and performs as intended. Let's explore the sub-activities of the validation process. A. Unit testing. Unit testing is performed to validate the correctness and functionality of individual software units or components. For example, in our mobile banking application, each module would undergo unit testing to verify that it performs the desired operations accurately, such as processing a transaction or generating a balance statement. B. Integration testing. Integration testing involves testing the interactions between integrated components to identify any issues related to interfaces, data exchange, or system behavior. In our mobile banking application, integration testing would verify that the front-end and back-end modules seamlessly communicate and that data is accurately exchanged during various user actions, such as transferring funds or checking account balances. C. System testing. System testing validates the entire system's functionality and performance as a whole. It ensures that the software system meets the specified requirements and performs adequately in different scenarios. In our mobile banking application, system testing would involve testing end-to-end user scenarios, such as creating an account, making a transaction, and viewing transaction history. D. User acceptance testing. User acceptance testing involves testing the system with end users or stakeholders to ensure it meets their expectations and requirements. It allows users to validate the software system from their perspective and provide feedback. In our mobile banking application, user acceptance testing would involve selected users or bank representatives testing the application's features, providing feedback on usability, and ensuring it aligns with their banking needs and expectations. Evolution. The evolution phase focuses on modifying and improving the software system over time to meet changing needs and requirements. Let's explore the sub-activities of the evolution process. A. Maintenance. Maintenance activities involve fixing bugs, addressing user issues, and ensuring the software's continued functionality and performance. For example, in our mobile banking application, maintenance activities could include addressing user-reported bugs, updating security measures, and optimizing performance to accommodate increasing user loads. B. Updates and upgrades. This sub-activity involves incorporating new features, improvements, or patches into the existing software system. It may be driven by changes in technology, business needs, or user feedback. In our mobile banking application, updates and upgrades could include adding new payment options, introducing biometric authentication, or enhancing user interfaces to provide a seamless banking experience. C. Configuration management. Configuration management ensures that the software system is properly controlled, versioned, and documented. It includes activities such as change management, version control, and release management. This sub-activity helps track changes, maintain consistency, and ensure the integrity of the software system throughout its life cycle. D. Re-engineering. Re-engineering involves modifying or restructuring the existing software system to improve its maintainability, performance, or other desired attributes. It may involve redesigning specific components, refactoring the code base, or migrating to new technologies. In our mobile banking application, re-engineering could be performed to enhance the backend server's scalability to accommodate increasing user demands. Throughout the software engineering process, each of these activities plays a critical role in ensuring the successful development and evolution of software systems. By following a systematic approach to software specification, development, validation, and evolution, organizations can deliver high-quality software that meets user requirements and adapts to changing needs.